So in this video, I want to go over a very common SAT like topic, and that's quadratics and how many solutions they have. So let's say we have a quadratic given by, let's call it x squared plus. Let me write it out actually. Let's say we have, uh, oops, like this, x squared plus 6x plus 8 equals 0. And we're asked how many solutions does this have? First off, very simple way to solve this. You can literally just graph the function. So let's say 6x plus 8. Okay? So something you'll notice is that there are, just graphing this function, I guess, with equals y, these are going to be the solutions, right? It's going to be anything where the value of y is equal to 0, right? So it's going to be -4 and -2 for our values of x, right? So there's three cases that could come up. One, you can have two solutions. You can also have just one solution, and that happens when you have some like a perfect square, right? So in this case, this blue line has one solution right here at -2, and then you can have no solutions. So the no solution case would be something like, let me see if I can pick numbers that work for this. If I do x squared plus 6x, should be plus 9. No, that's perfect for sure. Plus 10. Yeah. So the no solution case is, or where this is equal to 0, the no solution case would be it never intersects the axis whatsoever. It starts either above or below and opens in the opposite direction of the x-axis. So it is, though, important to know how to do it numerically as well. So like a way you can do this is, so if you're familiar with the quadratic formula, very common method for solving quadratics. If you don't know it, I would recommend. It's pretty important to know for the SAT. I have a video explaining it. I'm sure there's also plenty of instructions online that go over it. It's like a very fundamental part of algebra. So here we have the quadratic formula, right? And if you'll notice, there's actually one part of the quadratic formula that actually determines how many solutions we have, right? And that's this part right here, this b squared plus 4ac. Excuse me, it should be minus 4ac. That's my mistake. This determines how many solutions you have to your quadratic formula, right? Because this is the number that we're plus or minusing. So it will determine how many intercepts it has, because you can have a case where you have some number plus the quantity divided by 2a, or some number minus the quantity divided by 2a. And obviously both of these are going to produce your two different results because you're either adding or subtracting the different number. So in terms of what actually we see happens, in terms of like what values of b squared minus 4ac correspond to like what number of solutions, we really just have to look at its relationship to 0. So what I mean by is, for example, let's look at b squared minus 4ac for this equation. So b squared is 36 minus 4 times a, which is 1, times c, which is 8. So we get minus 32. Okay? And this equals 4. Okay? So if we look at this and we say, how does this number compare to 0? So 4 is greater than 0, right? So when you have a positive number, or 4 is greater than 0, you'll have two solutions, right? And we see that in our Desmos graph as well, right? For the x squared plus 6x plus 8, we had two solutions. Okay, so let's look at what happens when we have one of these other functions, right? So for example, we had x squared plus 4x plus 4, and that was equal to, let's say when this is equal to 0, and we want to know how many solutions does this have. Well, if we look here, we see one solution, yeah? So let's check. So we have b squared, so 16, minus 4 times a, which is 1, times c, which is 4, so 16. So 16 minus 16 is actually equal to 0. So when b squared minus 4ac is equal to 0, you'll have exactly one solution. All right. Now let's look at the last case we had, which was x squared plus 6x plus 10. Okay. So let's look at what this looks like when we evaluate it algebraically. We have x squared plus 6x plus 10. Okay. So when we evaluate this, what we'll end up with is, so b squared, 36, minus 4 times a, which is 1, times c, which is 10, so minus 40, and we get negative 4. Now, this is going to be the case where it's less than 0, a negative number, and this gives us no real solutions. And if you think about why this happens, it's pretty clear, right? We have b squared minus 4ac as a part of the quadratic formula, and we're taking the square root of it, right? And it's plus or minus. So when this quantity is equal or is less than 0, right, then we have the square root of a negative number, which is not real. We can't evaluate this without using like a placeholder like I, but that implies no real solutions, right? When this is equal to 0, then for our solution set, we'll have either plus or minus 0. And since plus 0 and minus 0 is the same operation, we just don't change anything. That's why we only have one solution. So that's kind of it. On the SL, actually, I guess one more example that comes up. And this is why I think it's helpful to know how to do it algebraically as opposed to just doing it on a graph, right? So let's say we have, let's call it 8. Okay, and let's say that this equation has no real solutions. Okay, so let's say we have, actually, let's say it has exactly one real solution. Okay, so if we have exactly one solution to this, and we want to know what is the value of c, right? Let's look and see first how it would look like on a graph, right? So we have x squared plus 8x plus c equals 0, right? And you can see here, it gave us an option for just a sec. We can add a slider for c, right? So we have this graph, and I guess we could say equals y, right? And we can play around with the different values and see what happens, right? It can be a little tricky. Right now, we're playing around with values, and we're not really seeing any activity. We don't really see anything being shown on the graph, right? Let's see what happens if I change it to 4x, and then c equals 4. Oh, there we go. Sorry, I had this off, right? So you can play around with these values and see when it gets to the point where it's exactly one intersection. And that could be a viable way to find c, right? So let's do it with 8x. So we can see here that we can't quite play with the value. So instead we have to increase this threshold so we can maybe reach that value that we need to. We can increase it a little bit, and we'll see here at 16, it looks like that is where it has one solution, right? Algebraically, though, to solve this, you can just plug it into this b squared minus 4ac, right? So we'll have b squared, which is 64, minus 4 times a, which is 1 times c, so 64 minus 4c. And we want to know what value of c this equals 0, because we want exactly one solution. And then evaluating this, we subtract both 64 from both sides, divide negative 64 by negative 4, and we'll get c equals 16. So both are viable ways to solve it. Sometimes it can be a little tricky to do it graphically, especially if the numbers aren't super nice. But this is like a surefire way you can also do it. Really comes down to personal preference. So I hope that all makes sense.